Hi everyone, welcome back. In this video we're doing a quick revision on speed time graphs. Be answering questions from 2022. By the way, exam questions from 2022 up to 2025, somewhere there. I want to be giving long explanation, but just clear answers and key points to help you get ready fast. Let's just start answering questions. Yeah, so as you can see, this one is from 2022 paper 1 GCE. We've been given a diagram, and in the first question you are asked to calculate the acceleration of the car during the first 5 seconds. So we're going to use the formula for acceleration. I'm sure you all know the formulas. The formula for acceleration is acceleration is equal to final velocity minus initial velocity over time. Yeah, so the question is saying during the first 5 seconds, meaning from here to there. So our final velocity is 20. So we're just going to indicate there. Say 20 minus the initial is 0. So 0 over the time is 5 seconds. 5 seconds is equal to 20 over 5. We're going to get 4 meters per second. Don't forget to indicate the units. So let's now go to question B. Question B. The question is saying find the value of t given that the total distance traveled was 550 meters. Yeah, so they want us to find the value of t, the t here, given that the total distance traveled for the whole journey was 550 meters. So what are we going to do now? So first of all, you're just going to ask yourself, what shape is this? So as you can see, the whole shape here is the trapezium. So to find the value of t, we're going to use the formula for area. When it comes to trapezium, it's in, so you say distance is equal to half a plus b times height. Yeah, so this is how we calculate the distance for trapezium. Now what's our a and what's our b and what's our h? So our a, you can choose any between this and this. So let's name this one as a, and let's name this distance as b. So now yeah, so what's our h? Our h is the distance from here to there, that's 20, and we've been given the distance, which is 550 meters. We're just going to replace here. 550 is equal to 1 over 2. Then our a from here to there is 25 minus 5 is 20. So we say 20 plus, what's our b? From here to there, it's t minus 0. So you say t minus 0. What's our height? Our height is 20. So you say 20. Then this one can just cancel it with this one, then we remain with 10 here. So you say 550 is equal to 10 times 20, it's 200, plus 10 times t, it's 10t, 10 times 0, it's 0. Yeah, so 550 minus 200 is equal to 10t. What's 550 minus 200? Should be 350. 350 is equal to 10t. We divide both sides by 10, even here by 10, then t is equal to 35. 10 into this one, it's 35. That's all. Let's go to the next question. The next question is saying, calculate the average speed for the whole journey. Yeah, so calculate the average speed now for the whole journey. So we say C. What's the formula for the average speed? Average speed is equal to distance over time. So average speed is equal to, we've been given the total distance, that's 550, no need to panic. Time, we're just from calculating the total time here, the t, let's see 35 here, so we divide by 35. Remember, calculators are not allowed, so should be practicing. We're going to have something like 15.71 speed meters per second, and that's our final answer. Okay, here comes the next challenge. Let's go. As you can see, this is 2022 paper 1, question 23, as you always. The diagram below is the speed time graph for an object. The object starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. It then travels at this speed for 8 seconds and finally decelerates to rest after 5 seconds. Yeah, so the information is indicated in the given diagram. Then the first question A is saying, find the retardation of the object in the last 5 seconds. So in the last 5 seconds, they're talking about this time interval from here to there. Okay, retardation, remember, it's the opposite of acceleration. The only different thing is that acceleration is positive, then deceleration is negative. Okay, then deceleration, okay, when it comes to acceleration, this is our initial velocity, then this is our final. But when it comes to deceleration, this becomes our initial and this becomes our final. And for that reason, deceleration is always negative. Okay, so let's answer the first question. So retardation is equal to final velocity minus initial over time. Then our final velocity is 0. This is 0. So 0 minus our initial is 10. The time is 5. It's equal to 5 into negative 10 is negative 2 meters per second squared. That's our answer for question A. Let's quickly go to question B. Question B is saying find the distance traveled in the first 10 seconds. So in the first 10 seconds, we are talking about this distance from here to there. This distance, the first 10 seconds, except on this part. Okay, so when we remove this part, still we are remaining with the trapezium. We are going to use the same concept we used in the previous question. So this is our A and this is our B. This is our height 10. So we are going to say distance is equal to half A plus BH. Then distance is equal to half our A from here to there is 8. Then from here to there it's 10. Our height from here to there is 10. Then distance is equal to this can cancel with this, we remain with 5. Then we say 8 times 5 is 40. So 5 times 8 it's 40 plus 5 times 10 it's 50. So distance is equal to 40 times 40 plus 50. We're going to have 90 meters. So this is our final answer for B. Let's quickly go to question C, the last question. The question is saying find the average speed of the object for the whole journey. So the formula for average speed is distance over time. So first of all, we are going to calculate the distance, the total distance for the whole journey. Remember, we are just from calculating the distance from here to there. So we have to calculate the distance from here to there, so that we get the total distance for the whole journey. So this is a triangle. Then the triangle, when we are calculating the formula for a triangle, we say C. So average speed is equal to distance over time. So we have 90. We already have 90. So we're just going to add plus in. Okay, let's calculate the distance for the remaining triangle. We say half BH, then half the breadth is 5, then our height is 10. So 5 times 10 is 50, divided by 2 is 25. 25 meters plus 90 meters. This is our total. We're going to get the total distance for the whole journey. We're going to get 115 meters. Then we come here, we say 115 divided by the total time is 15. What are we going to get? We're going to get 7.6 meters per second. And this is our final answer. And we are done with 2022 for both internal and the GCE. Okay guys, so this is now 2023 paper 1 GCE question 23. The question reads, the following diagram is a speed time graph of a car. The car starts from rest and acceleration from roughly 3 meters per second squared for 4 seconds until it reaches a speed of v meters per second. It then travels at this constant speed for 8 seconds. It finally comes to rest after t seconds. So as you can see from the diagram, so without wasting much of the time, let's just go straight to A. A is saying find the value of v. So v is velocity, so we are going to use the formula for velocity, that is v is equal to u plus at. Okay, so we're going to say velocity is equal to initial plus at. Then velocity is equal to, our initial is 0, so 0 plus our acceleration from the question is 3 meters per second squared. Here it is. So here we replace with 3, then the time is 4 seconds. The 4 here. So v is equal to 12 meters per second. Okay. Hope you've understood. So our v here is 12. Then let's go to B. B is saying, question B is saying, find the average speed for the first 12 seconds. So from the diagram, as you can see, our first 12 seconds is from here to there. So if you do this, this shape is trapezium. So let this be our A and this be our B. Remember, the formula for average speed is equal to distance over time. So we have the time, which is 12 seconds, but we don't have the distance, meaning we have to calculate the distance before we calculate the average speed. So we say distance is equal to, the formula for trapezium is half A plus B times height. Then distance is equal to half from here to there, it's 8. If you subtract 12 minus 4, you're going to get 8, meaning here we have 8. Then plus our B is from here to there is 12. Our height is 12. From here to there it's 12. So from here now, this can cancel with this, we remain with 6. Then 6 multiply by 8, we're going to get something like 48 plus 6 multiplied by 12, 72. Then the total speed, the total distance is equal to 120 meters. So now let's find the average speed. Average speed is equal to distance over time. So our distance is 120, then our time is 12. This and this cancels, going to remain with 10 meters per second, something like this. Okay, without wasting the time, let's just go to C. I'm sure you've understood. These are very simple things. Yeah, so C. So question C is saying find the value of t if the speed at t is equal to 14 is 4 meters per second. Okay, so this question was very simple but a bit tricky. Yeah, but that's why I'm here for you, to make things easy for you. Yeah, so let's dive in. So they are saying at t is equal to 14, the speed was 4 meters per second. So let's get this triangle here. They are talking about this triangle, so let's draw it here. So for a better understanding, let's draw a separate triangle here. Then they are saying at t is equal to 14, so we're going to indicate the 14 they are talking about should be here. Then the question is saying at this time the speed is 4 meters per second. This is what they are talking about. So we are going to use this information to calculate the deceleration. Deceleration is equal to let's use d, but I'm not sure what's recommended, but for now let's just use d. I just want to make you understand this clearly. So deceleration is equal to final velocity minus initial over time. Or let's just use final velocity is equal to initial plus deceleration t. This is acceleration. Yeah, so our final velocity is this 4a. In this case, we're going to use this data. So our final velocity is going to be 4. So we replace here with 4. Our initial is going to be 12 since we are decelerating. So this is our initial, then this is our final. So we say 12 plus 12 plus deceleration. Then what's our t? Our t is the time from here to there. 14 minus 12 is 2. So 4, this one crosses the equal sign. 12 is equal to, here we're going to have 2d. Then 4 minus 12, it's negative 8 is equal to 2d divided by 2 divided by 2. Deceleration is equal to negative 4 meters per second squared. Okay, so now let's find the value of this t. Since we have So now we have the deceleration is equal to -4 meters per second squared. Then the time, the one we are looking for, our final velocity is 0. Then our initial velocity is this 12 here. So now let's find the value of t. Velocity is equal to initial plus acceleration time. Our final is 0. Our initial is 12 plus deceleration -4t. So -12 is equal to -4t. Divide both sides by -4. -4. We're going to remain with t is equal to 3. That's all. Yeah, so that's a trick. Just use the data you have been given to find the deceleration. Then after that, you find the value of t. That's all. Yeah, so this is now 2023 paper 1, question 23 GCE. I mean internal. We are from answering GCE, so this is now internal. Yeah, the one I wrote. This is the one I wrote. I'm sure I got everything correct. Yeah, I'm sure. So the first question is saying find the acceleration of the car during the first 8 seconds. Yeah, so these are very simple things. The same way we are doing. Yeah, the formulas never change. These are very, very simple things. So acceleration is equal to v minus u over t. Acceleration is equal to final. Our final is 9 minus 0. Our time is 8. So acceleration is equal to 9 minus 0 is still 9. Then 9 divided by 8, you're going to get something like 1.125 meters per second squared. Next, B, distance covered in the first 14 seconds. So again, this is the trapezium. Yeah, so we are just going to let this going to be our A, and this is going to be our B. So from here to there, it's 14 minus 8, it's 6. Okay, so the formula for trapezium is B is equal to distance is equal to half A plus B times height. Then distance is equal to half. Our A is 6, our B is 14. Our height is 9. So distance is equal to 1/2. 9 times 6. 9 times 6, we're going to have something like 54 plus 9 times 14. We're going to have 126. 126. And distance is equal to this plus this. We're going to have 180. Divide by 2. Distance is equal to This should 90. 9 should be 90. Yeah. I'm sorry if I'm doing wrong calculations, but just concentrate on the procedure. Yeah, follow the procedure, then you do your things later. Question C is saying, find the value of t if the average speed of the car is 7 meters per second. So, question C, the average speed is equal to 7 meters per second. Then we are asked to find the value of t. So, let's find the distance. Already, we have found this one from here to there. Okay. We have found the distance from here to there. So, to find the total distance, we also need to find the distance from here to there. Then we combine. So, let's get this diagram here. Yeah. Okay, let's bring it here. It's looking like this. Then here it's 7, 9. Then here we have 14. Then here we have just t. So to find the value of t, this is the trapezium. So we are going to say this is our A, then this is our B. So the formula for trapezium is half A plus B. Oh no, my pen is running out of ink. Let me get the other one. Okay, so half A plus B times height. So then we're just going to divide by 2. So our A, the distance from here to there is 7. So we are going to say 7 plus B. B, the distance from here to there is 9. So plus 9 brackets. Then what's our H? Our H is the distance from here to there. It's t minus 14. T minus 14. I'm going to divide by 2. Then we expand. This multiply by this, it's 70. This by that, it's 98. 90 minus 126 divided by 2. Okay. Then this plus this, it's 16. So I'm going to have 16t. Then negative 98 minus negative 126. We are going to get negative 224 divided by 2 divided by 2. 2 into 16, it's 8. I'm going to get 8, yeah. 80. Then 2 here, 1, 1, 2. We're going to get minus 112. Yeah, so this is the distance of this one. Now let's add with this one. So this one plus 90 to find the total distance. So I'm going to add plus 90 So this one, negative 112 plus 90, we're going to get negative 22. So 8t minus 22. Yeah, so this is our total distance. Total distance. So from now we can find the average speed. So the average speed is equal to distance over total distance over time. By the way, we are looking for time, this t. Then the average speed we've been given the 7 meters per second. So we're just going to replace 7 is equal to, we've just found our total distance 8t minus 22. So we're just going to replace here, since we don't know the t, just going to say 8t minus 22 divided by t. Then we cross multiply, say 7t is equal to 8t minus 22. This will cross the equal sign. 7t minus 8t is equal to negative 22. Then this is just negative t is equal to negative 22. We cancel the sign. We're going to remain with t is equal to 22. That's all. Yeah, so we are also done with 2023 for both GCE and internal. Okay, so this is 2024 paper 1 GCE question 23. The question reads, the diagram below shows the speed time graph of an object. The object accelerates uniformly from 0 to p until it reaches a speed of 20 meters per second in 4 seconds, and then moves steadily from p to q for 6 seconds and finally comes at rest. Okay, so without wasting the time, let's just go to A. Yeah, so A is saying find the acceleration in the first 4 seconds. Okay, so these are very simple things. Yeah, so the same formula for acceleration, the same one we're going to use even here. So A, acceleration is equal to v minus u over time. So acceleration is equal to, our final velocity is 20, our initial is 0, divided by 4. Acceleration is equal to 5 meters per second squared. Simple. B is saying find the total distance covered by the object. So this is the trapezium. So we have the A, also have the B. So we're just going to say distance is equal to 1 over 2 A plus B times height. Then distance is equal to, our A is 10 minus 4 is 6, our B is 15, our height is 20. So distance is equal to, this one cancels, here we remain with 10. Then 10 times 6 we're going to have 60, 10 times 15 we're going to have 150. Then distance is equal to 150 plus 60, we're going to have 210. Yeah, if I've not mistaken. Yeah. The last question, question C, is saying Find the average speed in the last 4 seconds. So in the last 4 seconds. So to find the speed, we need to have acceleration. In this case here it's deceleration. So deceleration took 5 minutes, started from 10 to 15 seconds. So let's find the deceleration. See, deceleration is equal to final velocity minus initial over time. So in this case our final velocity is 0. Okay, take note. So 0 minus our initial is 20 divided by 5, because the deceleration took 5 minutes, 5 seconds I mean. So 5 into negative 20, we're going to have negative 4 meters per second squared. This is our deceleration. Then let's find our average speed in the last 4 seconds. Okay, so V is equal to U plus AT. Then V is equal to our initial is 20 plus our deceleration is negative 4. Then time we've been given 4. Then velocity is equal to 20. 4 times 4 is negative 16. And velocity is equal to 20 minus 16, it's 4 meters per seconds. That's all. So we're done with GCE. Let's now go to internal. Okay, so this is now 2024 paper 1, question 23, internal. A is saying calculate the retardation, that is deceleration of the particle in the first 10 seconds. So in the first 10 seconds, it's from here to there. Then the retardation they're talking about is this downslope. This is the retardation. Yeah, so let's quickly answer it. So acceleration, the retardation is equal to V minus U over T. Then retardation is equal to our final is 20. Our initial is 35, where it was coming from. Then time is 10. Retardation is equal to 20 minus 35. That is 15 divided by 10. Then retardation is equal to 1.5 meters per second squared. This is our A. Our B, the question is saying speed of the particle when t is equal to 31 seconds. Okay, so B, so always whenever they ask you to find the speed in the portion where there is a slope like this one, first of all find the acceleration. In this case it's deceleration. Yeah, so t is equal to 31 should be it's between, yeah, it must be between 40 and 25, so it must be somewhere here. So do this 𝐶1. So we need to find the retardation so that we find the velocity here. Okay, so we use what we have to find what we don't have. So in this case, retardation is equal to velocity is equal to initial over time, then retardation is equal to our final velocity is 0, then our initial is it started from 20, so 20 over 40 minus 25, that's 15. Then retardation is equal to negative 20 divided by 15. We're going to get something like 1.3, meters per second squared. So from here now you can find the speed using the time you've been given, that's 𝐶1. So I'm going to say speed is equal to initial plus 80, then v is equal to our initial is 20 plus retardation, this is negative, so negative 1.3. Our time is 9. Why 9? Because 40 minus 𝐶1 are going to get 9. So velocity is equal to 20 minus negative 11.7, then v is equal to 20 minus 11.7 are going to get 8.3. I'm sorry if this is not correct, but I think it's correct. So this is the speed. Then the last question is saying find or calculate the average speed of the particle for the whole journey. So I think this one I'm not going to answer for you. So all you have to do is to find the area of this one, the area of this shape, and the area of this shape. Then you sum up, just add them, that's it. Total distance. Then to find the average speed, you just divide by the total time. The total time is 40. What you are going to get is the answer for C, and it's called in 3 marks. So always the first one carries 1 mark, the second one 2 marks, then the third one carries 3 marks. Or it might not be always, but mostly, yeah. So we are also done with 2024 for both internal and external, and I'm sure by now you are comfortable with questions involving space-time graphs. Yeah. If you have any questions, let me know in the comment sections. Thank you for watching. If you've learned something new today, please don't forget to like, share, subscribe for more lessons every week. See you in the next lesson. Will fade eventually, so if our time is running out, day after day, we'll make